Hey class, today what we're learning about is we are going to learn about reflections. So our title for today will be called Reflections. And make sure you put the date, the day I'm recording this video. This is February 9th, 2016. But if you're watching this at a different time, use whatever date it is. Alright. So what we're talking about today is reflections, and this is probably a word that you've heard before. So you can talk about your reflection in a mirror. You might say you can see your reflection in a puddle. The idea is it's something, it looks just like you, but it's been flipped, okay? So it's flipped around. And so what we're going to do with reflections is taking something and flipping it across a line. The first thing we're going to glue down is we're going to glue down our vocabulary. Okay, so put this near the top. I'm going to pause real quick because I have to go get some glue. Alright, so we're going to run through our vocabulary here. So go ahead and get this box glued down. Remember, pause this video at any time if you think I'm going too fast. Just pause it. You can raise your hand and ask questions as well. Alright. Okay, so a reflection. A reflection is a transformation. The word transformation means we just take a figure and we do something to it. We transform it. We change it. So it's a transformation in which a figure is reflected across a line creating a mirror image. Okay, a mirror image, kind of like you can think of it as like a backwards image. Okay, that is what the word reflection means. Alright, the next thing we have here is the line of reflection. The line of reflection is just whatever line we take and reflect our image across. So line of reflection is the line the figure is reflected across. Our image is going to be the same distance, our pre and post image is going to be the same distance from this line. So our pre and post image are same distance from the line. Alright, so the same distance from the line. Alright. Okay, the last definition we have here is our line of symmetry. Our line of symmetry is going to be used with different shapes. And it's the line of symmetry is a line a line that you reflect over is called a line of symmetry. Two M's there in symmetry. The idea is that whenever you draw this line, so if I draw a shape here, like a square, if I draw a line like this, we can kind of fold this shape up on that line, and it's the same on both sides. Okay, you're able to kind of fold along that line, and you get the same image on both sides. Like if we took a heart, you could draw a line down it like this, and if you folded it up, it would match up on both sides. But let's say I took something like a parallelogram, and I tried to draw a line of symmetry like this. Well, this point, if you folded it right along that line, this point would end up over here. It wouldn't line up with the bottom of the image. So it's a line that you could fold across, and then your line lines up on both sides. All right, next thing I'd like you to glue down is this one. All right, so this is the next one you're going to glue down. I'll just put this right below the last. And we're actually going to do some reflections. We're going to reflect some points. Okay, the first thing we're going to do is we're going to plot this A, 0, 2. So I'm going to plot that point. Oh, let's see, 0, 2, right there. I'm going to label that guy A. And what it asks me to do is it says in the x-axis, you can replace this in with across the x-axis. It means the same thing. It's just kind of a weird terminology. And so what you do is you're going to take this point and we're going to flip it over the x-axis. You can think about folding your paper along the x and seeing where it would show up. Okay? And so point A is going to show up right down here if you flip it over the x-axis. These points should be the same distance from the x-axis. This is our first image. A is called our pre-image, and then this point we're going to call it A. We're going to put a little prime after it. The prime always indicates our post. Okay? And so after we flip this across the x-axis, A prime is at 0, negative 2. All right, now we're going to flip this. Point B, 5, 1. 5, 1 right here, and they want to flip it across the y. Remember, the y is up and down. So you're going to take this point and it's going to be flipped directly across, and it's going to land right over here. Okay? Remember, same distance from the y-axis. So this was B. This one is B prime. Okay? That's pre-image, post-image. So B prime is at negative 5, 1. Next, point C, negative 4, 3. 2, 3. This is point C. They want us to flip it across the line x equals negative 3. If you don't remember, x equals negative 3 is a vertical line at negative 3 on the x-axis. So it's this line right here. We're going to take this point and we're going to flip it right across that line, and it's going to land it's 1 unit away. It's going to land 1 unit away right over here, C prime. Okay. If you have to work with either 3 or 4, you're always going to have to graph them to see where those lines are in order to flip them. And this is C prime is the point negative 2, 3. Okay, we've got one more example of reflecting a point. We're at 4, 0, which is right here. This is point D. And they want to flip it across y equals 2, which is a horizontal line at 2. Once again, D is 2 units away, so we got to go 2 units away right up here, and that's D prime. So D prime is at 4, 4. Okay, so you can always, if you are reflecting a point, you can always graph it, draw on whatever line you're reflecting it across, and then plot your new point. This next thing we're going to write down is just a shortcut. So go ahead and glue this underneath. These are just shortcuts. They're not necessarily needed, but they save you time. Oh, the announcements are coming on. I'm going to pause.
Teachers, by this interruption, I have some announcements.
All right, so like I was saying, these are shortcuts, so you can always graph your points and reflect them, but these are just going to be shortcuts. So if a point xy is reflected in the x-axis, so we're going across the x-axis, just like point A was, all right, is reflected, its image is the point, and all you have to do is keep your x value the same and make your y value and make your y value negative. So up here we kept our x value the same, which was 0. Our y value changed from 2 to negative 2, okay, from y to negative y. If xy is reflected across the y-axis, so it's reflected across the vertical axis, it's going to become the point, and this is backwards, negative x, y. Just like point B, it started out as 0.51, the x turned negative, negative 5, and my y value stayed the same. So these are just shortcuts. So these are shortcuts. You can always graph them, though. Alright, so I'm going to go to the back. I already glued these down. Pause the video if you need a minute to glue these down. This right here, reflection theorem, this is just a new word I want you to learn. So it says a reflection is and it's an isometry.
Jonah Ninig and Isabel Sample.
Okay, so this is an isometry. An isometry is this right here. This means that the pre and post image are congruent. Meaning they're the same size and same shape. Okay, so if we do a transformation that's an isometry, that means that the pre and post image are going to be the same size, same shape. They might be facing different directions, they might be located in different areas, but they are going to be the same size. We will have a couple transformations that aren't isometries, but we'll get to those later. Alright, next, how many lines of symmetry does the figure have? Okay, remember, a line of symmetry is a line that you can draw where if you folded the shape up along that line, it would match up. Okay? So if we start with this oval, the first thing I think is that I could draw a line like this. And if I folded along that line, these points would match. Okay, all these points would match up. Okay? There's actually two lines of symmetries in this one. You can also draw one vertically. And if you folded, the sides would everything would match up. There's only two there. If you go to this nice five-sided shape here, the first one I see is draw a line directly down. Alright, and if you folded it up, these little points would match. Okay. There's also one like this. These points would match. Let's see, there's one like this. There's one like this. And I think I'm forgetting one. This. Alright, so this shape has 1, 2, 3, 4, 5. This one has 5. This one has 2. And let's see. This one has 1, 2, 3, 4, 5, 8 sides. Okay. And this one, if you draw directly point to point, okay, everything would match up. It also has them right here. Side, middle of side, middle of side. So I think this one has a whole bunch. Okay, if you're confused about what I'm drawing, please call me over. I would like to help you out. So all of these lines, if I took and folded this shape along these lines, it would match up. That looks kind of fun. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. I should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't think there's 8. I think there's 8. 1, 2, 3, 6, 7. Yep, 8. All right, 8. That one has 8. What I would like you to do now, so that's the end of our notes. What I would like you to do is I'd like you to take these 3 examples that we have. This graph paper, you can toss this. Ended up not needing that. I would like you to glue this down in your binder. Okay, so I'd like you to glue this down in your binder. Above it, I'd like you to put the words practice. Okay, and I would like you to find the lines of symmetry on these 3 shapes. Whenever you get finished, you will get this checked by me. This is like a little exit slip type thing. This will be worth just a couple points, kind of like a bell work, more, opposite of a bell work maybe. And then you can get your homework. Okay, so this is like our checkup to make sure we watch the video and make sure everybody is on track. Once again, it'll be worth a couple points just to help you guys out a little bit. So, if you need help with this, please let me know. This is where I'll come and make sure you guys understood the video. This is your homework. I would like you to do all of it unless I tell you something different in class. All right. Thank you for watching, and have a great rest of your day.